This is part 3 of the lesson on combination of functions. And before we begin part 3, it is very important that you review parts 1 and 2 because this is just a review of parts 1 and 2 and also the lesson that dealt with finding the domain of a polynomial and rational functions. It's a good idea before we begin this to go back and review how to find the domain of polynomial and rational functions. So in that lesson, we did talk about given a rational function, how to find the domain, and so on. Okay? All right, and we also saw in this lesson that the domain of all polynomial functions, it would be all real numbers. Okay, so that was discussed in that lesson. In lesson 1, in part 1 rather, of combination of functions, that's where we talked about the definition of what we mean by the algebra of functions, by combining functions, whether it be adding, subtracting, multiplying, or dividing. So we saw the different notations that were involved. And basically, we saw that given two functions, we can come up with a new function by adding, subtracting, multiplying, or dividing. What we're going to do now is look at more of these examples, a few more of these examples, but in particular, we're going to look at, well, all right, we got this new function right here. What's the domain of that new function? This is what we're going to talk about. Okay. All right, so let's look at this example. Number 1. Suppose we had this function. We had function f of x, let's say, is negative 3x plus 7. And g of x, let's say, is 4x plus 3. All right, and let's find each of the following. Find each of the following. Okay, letter A. Suppose you want to find g plus f at x. All right, well, we saw in a previous lesson, I'm going to go ahead and use part 2. We saw in a previous lesson the definitions, the definition of sum, difference, product, quotient. And so we know that this notation right here, g plus f at x, remember, it doesn't mean times x, it means at x, means g of x plus f of x. Now remember, in a previous lesson, we also talked about the commutative property. So we saw that addition was commutative. So adding g of x plus f of x is the same thing as saying f of x plus g of x. So the addition, the order in which you add does not matter. Okay, but it's always a good idea to, when you do these operations, that whatever's listed first, whether it's listed first here or listed first in the quotient rule, you put that first. All right, because remember, the quotient rule is not commutative. Okay, so basically what you're going to do to find your new function, to find this, is just like as we did before. Well, here's g of x. You know g of x, that's this. So 4x plus 3. Plus, and you know f of x is negative 3x plus 7. And then you add them up. And so you just found that g plus f at x is equal to, combine like terms, 4x and a negative 3x is x. 3 plus 7 is 10. So there's your new function. So g plus f at x is equal to x plus 10. All right, now what we want to do now is this. So this is what, basically in terms of this, our new part, although it is a review. It is a review from a previous lesson, and that lesson was on finding the domain of polynomial and rational functions. What we want to do now is this. Now we're going to find the domain of g plus f at x. Okay, now we're going to find the domain of g plus f at x. Well, remember in the previous lesson we talked about polynomial functions, And we saw that polynomial functions, the ones that we looked at now, remember, only the ones that we looked at were, they look like this. They were a line. We looked at quadratic functions where the parabola either went up or down. And we did see, and I think it was on this last page, or maybe one of the other pages, this right here, we looked at a cubic function, and we saw that this was indeed a polynomial function. If you graph it, notice that it's continuous. Okay, you have a smooth curve like this. This is a polynomial function. It's continuous as you go from left to right. So what I want you to notice is that this right here, so if I look at this in terms of, and I just want you to think like this for a moment. Let this be y right here. So we have y equals x plus 10. So you'll notice that this is a line, right? So we know that in terms of this function, this line is a polynomial function. So the domain would be all real numbers. Domain would be negative infinity to infinity. Because if you think about it, then think about what you're doing here in terms of domain. Are there any x values I cannot use? So are there any x values that would make this right here undefined, let's say? There isn't any, because no matter what value I use for x, I'll get a y value. So if I use a decimal, any real number, decimals, fractions, integers, whatever it may be, irrational numbers, rational numbers, I'll get a value for y. So the domain will be negative infinity to infinity. So remember, one of the things we learned in the previous lesson is that all polynomial functions, for all polynomial functions, the domain is all real numbers. All right, and in terms of an interval notation, you wrote it as negative infinity to infinity with equal signs. Okay, part B. Suppose you want to find, let's say, f minus g at x. F minus g at x. Okay, well, remember what we mean by that, the definition. So by definition, I can write this as, and first of all, remember that subtraction is not commutative, so the order does matter. So since f is listed first, I must put f first. So that's f of x minus g of x. And then what we did in a previous lesson, and that, remember, is lesson 1. So we did, well, part 1 rather. So that's where we started talking about this. So what we did was, in place of f of x, we substitute what that function was equal to. So that was equal to negative 3x plus 7. And remember what else we talked about. You see where you're subtracting? You got to put that in parentheses because you're subtracting all of the terms of g of x. So remember, we had to put that in parentheses. So that's going to be 4x plus 3. Now the next thing we did was we got rid of the parentheses, so I distributed that negative through here. So I get negative 3x plus 7 minus 4x, because if you think of this as negative 1 if you want to, negative 1 times 4x is negative 4x. And then negative 1 times a positive 3 is a negative 3. And then combining like terms, negative 3x and negative 4x is negative 7x. Positive 7 and a negative 3 is a positive 4. And so that is your function f minus g at x. Now, remember, if you look at this, isn't this a linear function? And that's a polynomial. And what do you remember about polynomials? The domain of a polynomial is all real numbers. So now we're going to say the domain of f minus g at x is negative infinity to infinity. Okay? All right. So remember, one of the things we saw before was this. If you look at the domain of this linear function is all real numbers. The domain of this linear function is all real numbers. So when I add them, I get a new function, and the domain is still all real numbers, because I end up with a linear function. A linear function plus another linear function gives us a linear function, which gives me the domain of all real numbers. Okay? All right, now let's look at this one. So same thing here. So a linear function subtract another linear function gave me a linear function, right? And so what's the domain of a linear function? All real numbers. It's a line. And so a linear function, the domain is all real numbers. Okay? Part C. Part C now, let's look at part C. So when look, what I want to do in part C is look at the product. So let's say we want to find g times f at x. So remember, that means g times f. Well, by definition, remember that means g of x times f of x. Okay? And then what you did was, in place of g of x, you wrote out what that function was equal to. Well, g of x, remember, is 4x plus 3. But remember, we put that in parentheses because that had to be multiplied by this function f of x. We've got to put that in parentheses. And f of x is negative 3x plus 7. Now that's where we're at. Now remember, what we did at this point was we had to get rid of the parentheses. So if you notice, I'm multiplying two binomials. And so when I multiply them, I'm going to use a FOIL method. 4x times negative 3x is a negative 12x squared. The outer, 4x times 7 is a positive 28x. The inner, 3 times a negative 3x is a negative 9x. And the last, 3 times 7 is a positive 21. When I combine like terms, I get negative 12x squared. Now let's put in descending order. 28x and a negative 9x is a positive 19x, and then plus 21. And so that is g times f at x. Okay? All right, now let's look at the function we have. Remember, this is a quadratic function. Quadratic function, right? And a quadratic function is a polynomial function. And so what's the domain of a polynomial function? Well, remember, a quadratic function in this case, and since a is negative, it's going to be a parabola opening down. And so if you look at this, the domain would be negative infinity to infinity. Remember how we did this going from left to right? Negative infinity to infinity. That's your domain. So the domain of a polynomial function is all real numbers. So domain of g times f at x is negative infinity to infinity. Okay? All right. Now let's look at D. So when we look at D, this is going to be our quotient. So let's say I want to find f divided by g at x. F divided by g at x. Okay, so let's look at this. By definition, remember, by definition, that means f of x divided by g of x, right? Okay. And so f of x, remember, in this case is this right here, negative 3x plus 7, and g of x is 4x plus 3. So I have negative 3x plus 7 divided by 4x plus 3. And then at this point, what you want to do is try to factor if you can and reduce, because if you can reduce, you want to do that. But in this case, the GCF of both of these numerator and the denominator, both of these polynomials, is 1. So there's nothing else you can do in terms of reducing. Okay, so at this point, we would say f, just like we did here, f divided by g at x is this right here, negative 3x plus 7 divided by 4x plus 3. Okay? Now, let's find the domain. Okay, so I'm going to say find the domain of f divided by g at x. Okay, now here's where we got to remember something about our discussion of this lesson. So remember, parts A, right here, in part A, our new function is a polynomial, right? Okay. Our new function is a polynomial for part B. For part C, our new function is a polynomial. Well, remember, we know that the domain of all polynomial functions is all real numbers. But if I look at part D, though, if I look at my new function here, is that a polynomial function? No, it is not. What function do you think this is? Well, remember in our previous lesson, we talked about finding the domain of polynomial and what other function? Rational function. So this right here is a rational function. That's a rational function. And remember, when we talked about rational functions, we saw that in a rational function, our denominator cannot be 0. So now we have to talk about, well, since I have a rational function, this function is going to have restrictions. The domain is not all real numbers in this case, in this particular case. Now, it could be all real numbers, but in this case, it's not. And the reason is this. You remember when we talked about rational functions in that lesson previously? We saw this. We saw, well, I got to find restrictions, right? So remember, we must find restrictions. Must find restrictions. So since it's a rational function, we must find restrictions. So in other words, I got to find out what x will make this denominator 0. I don't care about the numerator. The numerator can be any number. It could be 0. It could be any real number. But the denominator cannot be 0. So I got to find out what x will make this denominator 0. Remember, what we did was we took the denominator, just the denominator, and we found out what made that equation equal to 0. Well, what made 4x plus 3 equal to 0? Okay? And so notice that that's linear, so all I do is subtract 3 from both sides. And so I get 4x equals negative 3, and then divide by 4. I found my restriction. X equals negative 3/4 is a restriction. So this is the only real number that makes this function undefined. So remember what that means. X equals negative 3/4 is the only real number that makes f divided by g undefined. Okay, that makes f divided by g undefined. Now remember what we did though. Remember, you got to write this as interval notation. So remember what we did was we put this on the number line, this number, negative 3/4. And do you remember what else we did? We crossed it out, yep. And so notice that this number divides this number line into 2 intervals. So my domain would be every real number on this interval except the negative 3/4. And so what we did at that point was we kind of went across the number line, and so we said, well, we're going from negative infinity to negative 3/4. And remember what else we put? Since I cannot use negative 3/4, we had to use parentheses. Union, because remember there are 2 intervals, so the domain is the union of 2 intervals. Negative infinity to negative 3/4, and from negative 3/4 to infinity. Okay, so the domain of a rational function, so remember, first of all, the domain of a polynomial function is all real numbers. So every real number I can use, and I'll get a y value. But for a rational function, the domain is not all real numbers. Not always. In here, there will be a situation where something will, a value for x will not work. And I'll do one in a little while, what I'm talking about. But here, the domain is all real numbers for a polynomial function. Here it is not. So we have to ask ourselves, all right, the domain is not all numbers because x equals negative 3/4 makes my denominator 0. So it makes this function undefined. So I got to state it. So my domain will be negative infinity to negative 3/4, and from negative 3/4 to infinity. So this means all real numbers except negative 3/4. So make sure you understand how to write the domain of a rational function in interval notation. Okay? Let's look at part E. All right, suppose in part E I had this. All right, suppose this was part E. So remember in part D I had f divided by g. All right, suppose now I have g divided by f. G divided by f instead. Okay, well, same thing. Same thing. By definition, that means g of x divided by f of x, right? And so remember, g of x in this case is 4x plus 3. And f of x is negative 3x plus 7. Okay? All right, and notice in this case, if you can reduce, you can. So you would have to factor first and then reduce, but you cannot factor any of that. But notice, I want you to realize that g divided by f is equal to this function. Okay? And now you can ask yourself, is this a polynomial function or is this a rational function? Well, that's a rational function. Remember, rational function is a polynomial divided by a polynomial. That's a rational function. So remember when we part of the discussion a while ago was I asked you what kind of function is this? Well, we say that's a polynomial function. It's a linear function, but it's still a polynomial function. That's a polynomial function, right? All right, and then a rational function is a polynomial divided by polynomial. Okay. All right, now remember, I want to find the domain of this now. All right, so first of all, here's my new function right here. It turned out to be my new function. My new function turned out to be a rational function. And we know that the domain of a rational function, just think about our discussion a while ago, is all real numbers except where the function is undefined. Except where the function is undefined. So we got to find out, where is this undefined? Well, remember, a rational function is undefined when the denominator is 0. So I got to find out, where is the denominator equal to 0? So where is negative 3x plus 7 equal to 0? For what value of x? So I just solved that equation. It's this right here. This equation is linear. So I'm going to subtract 7 from both sides. So I get negative 3x equal negative 7. And then I'm going to divide both sides by negative 3. And so I get x to be, a negative divided by negative is a positive, so I get x to be 7/3. So what I found here is the restriction. So my domain in words, my domain is all real numbers. Domain is all real numbers except 7/3. That's what I found. Domain is all real numbers except 7/3. But they're going to ask you to write this as an interval. So think about what you're doing. So you can put this in a number line. So remember, the domain would be all real numbers except this. So you can put this in a number line and cross it out. So the domain is all real numbers except 7/3. All right, so let's talk about how to write this now. So to write this, remember, you're going to go from let me get my ruler. So you're going to go from negative infinity to 7/3. Okay, with a parentheses because I cannot use it. That's not part of the domain. Union, and then 7/3 to infinity. So negative infinity to 7/3. That's this interval, and then this interval is 7/3 to infinity. All right, so remember, divide into two intervals. This one exclusion divided the number line into two parts. So this interval is this, and this part is this interval. Okay? All right, so that was number one. Let's look at this next example. All right, suppose we had this. That would be number 2. All right, suppose in number 2, I had f of x is 6 minus 5x, and g of x, let's say, is x squared minus 64. Okay? Okay, now let's find a. F plus g at x. F plus g of x. Well, remember, by definition, that means f of x plus g of x, right? And then at that point, remember, that's where you actually state what each of these are. So f of x, remember, 6 minus 5x plus g of x is x squared minus 64. Now, guys, it's not necessary to put parentheses here because I'm just adding these. If I were subtracting, that was a subtraction here, it would have been necessary to put parentheses because you're subtracting both terms. You're going to see this in a little while. Combine like terms. Let's put in descending order. I get x squared minus 5x, and then 6 and a negative 64 gives me a negative 58. All right, so that is f plus g at x. So in the blank, you would say f plus g at x is equal to this. Okay? Now, I want you to tell me, is this a polynomial function or is this a rational function? All right, this is a polynomial function, right? So a polynomial function, this is quadratic, so it's a polynomial function. Okay? So we're going to ask what's the domain of a polynomial function. And so remember the domain of this polynomial function. So the domain of f plus g at x is blank. What are you going to put? You put negative infinity to infinity. Because what we mean by that is that no matter what value I put for x, I'll get a y value back. All right, now part B. Suppose I want to find g minus f at x. All right, so by definition, that means g of x minus f of x, right? Okay, so then you're going to say, well, g of x is x squared minus 64, because that's what we know g of x is. But remember, this time you're subtracting, so you're gonna have to put that in parentheses right here, because you're subtracting every term that's in here. So f of x, remember, 6 minus 5x. I get rid of the parentheses. That's why you had to put in parentheses so you could subtract both terms. I get x squared minus 6x. When I subtract 6, I get a negative 6. When I subtract negative 5x, I get a positive 5x. And so therefore, g minus f at x is equal to x squared. Combine like terms. A negative 6x and 5x is a negative x, and then minus 6. All right, now, this, remember, is a polynomial function, right? It's a polynomial function. And it kind of makes sense because this is what kind of function. Okay, obviously, that's linear, but is a linear function a polynomial function? Yes. Is a quadratic, that's quadratic. Is a quadratic function a polynomial function? Yes. So if I add two polynomial functions, or if I subtract two polynomial functions, I should end up with a polynomial function. So these are both polynomial functions. And remember, the domain of a polynomial function is all real numbers. That's the domain of a polynomial function. All right, so the domain of g minus f at x is, you would say, all real numbers. So negative infinity to infinity. Part C. So let's say in part C you want to find this. Let's say in part C you want to find f times g at x. So remember, by definition, that means f of x times g of x. Okay? Well, let's go ahead and write out what we know. We know that f of x is 6 minus 5x. Now remember, we got to put that in parentheses because we're multiplying these. And then g of x, we know, is x squared minus 64. Okay? So if I multiply, now notice those are two binomials, so I'm going to go ahead and use the FOIL method. So 6 times x squared first. 6 times x squared is 6x squared. The outer 6 times 64 is going to give me, let's see what that is, 6 times 64, 384, so minus 384. A negative 5x times x squared is a negative 5x cubed. right? Cube. And a negative 5 times 64 will give me positive, negative 5 times a negative times a negative is a positive. So it's going to be a positive 320. And putting that in descending order, I'm going to get negative 5x cubed plus 6x squared and a negative 384 and a positive 320 gives me a negative 64. So f times g at x is equal to this. Now, what kind of function is this? Polynomial. That's a polynomial function. And what's the domain of a polynomial function? So the domain of this, f times g at x, is all real numbers. Okay? All right, D. Suppose in part D, I want to find, let's do g divided by f first. Let's do that one. Okay, well, g of x, remember, is x squared minus 64. And f of x, remember, is 6 minus 5x. Okay? Now, remember, we did say this earlier. We said that if possible, go ahead and factor and reduce. Reduce if you can, but to reduce, you would have to factor. And if I factor this, notice that is the difference of two squares. But it's not going to help, because if I look at this, that's x minus 8 times x plus 8, right? And then over here in the denominator, that's 6 minus 5x. Are there any common factors to reduce? No, there are no common factors. So just leave it like this. So that is, this right here, is g divided by f at x. Now, if you wanted to, you could say this. It does not matter. You'll still get credit for that. Okay? Does not matter. But since I couldn't reduce, leave it like that. Okay, now let's talk about the domain. So let's find the domain. Now, first of all, is this a rational or a polynomial function? Well, that's a rational function, right? A polynomial divided by polynomial. So that's rational. So now we go through that discussion all over again now. Don't forget about the discussion. Okay, so let's talk about the domain of a rational function. So that's rational. Okay, that's rational. Okay, so we got to find out, remember, to find the domain of rational function. The domain of rational function is all real numbers except except the values of x that makes this rational function undefined. That's what we talked here, right? All real numbers except where the function is undefined. Well, the function is undefined whenever the denominator is 0. So what I'm going to do here is I'm going to ask myself, where is 6 minus 5x equal to 0? That's what I'm asking. So that's linear, so I'm going to go ahead and solve for x. I'm just going to go ahead and add 5x to both sides. So I get 6 equals 5x, right? And I get x by itself. I'm going to divide both sides by 5. And I found my restriction. So the only value of x that makes my function undefined, so this is where g divided by f is undefined, is 6/5. So that's what I just found. Okay? All right, now let's go ahead and discuss what that means. Okay, so what that means is this. That means that in terms of my number line, my domain will be all real numbers except 6/5. So notice that 6/5 divides the number line into two intervals, into two parts. So when I look at this in terms of the values for x, I could say it will be from negative infinity all the way to 6/5. So the domain will be negative infinity to 6/5, parentheses, and then union, and then the other part will be from 6/5 to infinity. So it's very important you know how this is supposed to look. So again, this right here means all real numbers except 6/5. That's what that means. Okay? So that's domain of g divided by f. Okay, now let's look at part E. Suppose part E now, you want to find in part E let's say you want to find f divided by g this time. Okay. Well, by definition, this means f of x divided by g of x, right? Okay. So f of x is 6 minus 5x. G of x is x squared minus 64. Okay. So notice that, again, our discussion earlier, even if you factor x squared minus 64, which is x minus 8 times x plus 8, you can't reduce. So just leave it like this. So you would say f divided by g at x is this, 6 minus 5x divided by x squared minus 64. Okay? What I want you to notice now is this. This is a rational function. And so the domain of a rational function is all real numbers except whatever makes this function undefined. Well, a rational function is undefined where the denominator is 0. So I got to find the restrictions. So the restrictions would be where the denominator is 0. That's my restrictions. Now, before I go on, notice in the previous problem, see when we said the denominator equals 0, this was linear. This is no longer linear. What is this? That's quadratic. That's right. And so notice I could do one of two things. I can factor, or I can use the square root property because the x term's missing, right? See, you don't see an x term. You see an x squared term. You see a constant, but you don't see an x term. So what I'm saying is that if you wanted to, you could have said, well, that's going to be x squared equals 64, and then take the square root of both sides. Don't forget plus or minus, though. And so you get x equal plus or minus 8. Now, if you wanted to factor, you could. If you wanted to factor, you could. You would say x minus 8 times x plus 8 equals 0. And then you would set each factor equal to 0. So you'd say x minus 8 equals 0, x plus 8 equals 0. And then you would solve each linear equation. And you would get x to be 8 and x to be negative 8, just like we had here. So you found your restrictions. So my domain would be all real numbers except 8 and negative 8. That's what you found. But you have to put this, so in words, this is what we found. So in words, the domain is all real numbers except where x equal 8 and negative 8. Okay, those are my words. But we have to put this in interval notation. And remember from a previous lesson what we did. You put those on the number line in order. So you have to put negative 8 first, then you have to put positive 8, and then we cross them out. So notice that this time, so remember the previous one, how many restrictions were here? How many restrictions did we have? We only had one. So this one restriction divided the number line into how many parts? 2. Hence the 2 intervals. How many restrictions do we have here? There are now 2. So those 2 restrictions are going to divide the number line into how many parts? 1, 2, 3. So in terms of interval, you're going to say domain of f divided by g is, and then you say, okay, you do each one. You're going from negative infinity to negative 8, parentheses, union, and then from negative 8 to positive 8, union, and then from 8 to infinity. And so notice 3 intervals correspond to those 3 parts of the number line. So this part is this one, this part is this one, this part is this one. Okay? All right, now one more thing I got to tell you about this. All right, now you have enough to be able to do your assignment, but I just wanted you to think about this for a moment. And we're not going to do all parts of the combinations. We're just going to look at quotient. So let's say number 3 you had this. F of x, let's say, is 2x minus 1. And g of x, let's say, is x squared plus 4. let's say. Oops, sorry. All right, so f of x is 2x minus 1. G of x is x squared plus 4. Let's suppose I want to find f divided by g at x, okay? F divided by g at x. All right, well, by definition, what does that mean? Well, that means f of x divided by g of x, right? Okay, so that means, well, then that means that the numerator must be 2x minus 1, because that's what f of x is, 2x minus 1. The denominator, g of x, I've got to write this here, so that's x squared plus 4. And remember, this is the sum of two squares, right? So the sum of two squares is prime. You cannot factor that. So there's your answer for this right here. So f divided by g at x is 2x minus 1 divided by x squared plus 4. So that wasn't a difficult part. That was easy. But here's what I want you to think about now. Okay, let's find the domain. Okay, so let's go back over here. So remember when we did this? When we did this one? So we looked at this rational function and we said the domain of this rational function was all real numbers. All real numbers. So this means all real numbers except -8 and what else? +8. Those are restrictions. So when I found the restrictions, or when I found the domain of this rational function, I asked myself, what makes the denominator 0? Because the domain of a rational function is all real numbers except what makes this undefined. And a rational function is undefined when the denominator is 0, right? Okay, let's use that right here. So this is a rational function, correct? Okay, that's rational. Because if you look at it, I have a polynomial divided by polynomial. All right, so what I got to do now is find out what makes this rational function undefined. Well, rational function is undefined when the denominator is 0. So ask yourself, where is x squared plus 4 equal to 0? That's what you got to find. Well, if I were to bring 4 to the other side, let's look at that. X squared equal -4. We had a discussion in a previous lesson, beginning of the semester. We also had that discussion last semester. Is there any real number multiplied by itself that will be a -4? You may say, well, what about 2? Well, 2 times 2 is a +4, right? So that doesn't work. Then you may say, well, what about a -2? Well, a -2 times a -2 is also a +4. In fact, if you square any real number other than 0, if you square any real number, it's will always be positive, won't it? So is there a situation, is there a real number where x squared plus 4 is equal to 0? The answer is no. No real number is a restriction. No real number is a restriction. Because no matter what number I use, I'm never going to get 0. No matter what real number I use, I'll never get 0 down here. So remember we said this. We said the domain of a rational function is all real numbers except what makes it undefined. Is this function ever undefined? F divided by g at x is never undefined. It's never undefined. So what that means is that my domain is all real numbers. That's what that means. Your domain is all real numbers. Because remember, the domain of a rational function is all real numbers except what makes this undefined. And this is undefined when the denominator is 0. Is the denominator ever 0? Nope, it's never 0. So that's your domain. So I just wanted you to see this, that because I didn't want you to get didn't want you to think based on our previous discussion that there's always going to be something down here that your rational function, there's always going to be a restriction. I don't want you to think that. The only time you're going to get a restriction, you will not get a restriction, is if you can't find a value of x that makes this undefined. That makes it 0 right here. Okay? All right. Okay, so that's going to be the end of this lesson. So this was part 3 of combination of functions.